Alright everyone, in section 11.3 we're going to be moving back to probability and stats for a little bit. In this section we're going to talk about the probability of multiple events, so adding and multiplying probabilities. This stuff can get a little bit confusing, but keep in mind this is all a review from last year in geometry. So just be confident with it. Know you've seen this before. Hopefully the closer that you pay attention, this will kind of slowly start to come back to you a little bit. So to start out, we're going to talk about multiplying probabilities. So to find the probability of two events occurring together, you want to decide whether one event affects the other. So when I'm talking about event A affecting event B, I'm really asking myself, are these events independent or dependent? So in the first example, we're just going to be classifying situations, and I want to ask myself, are these outcomes independent of one another? In the first example, I eat a yogurt for breakfast and my neighbor eats a muffin. Here, I'm eating yogurt, we're all stuck in our houses, my neighbor has no idea what I'm eating for breakfast, so my actions had no influence over what she did for breakfast. So, those events would be independent. In the next example, I drink 4 cups of coffee in the morning and I feel jittery for the rest of the day. Due to the fact that coffee has caffeine and that has an effect on your body, drinking all of that coffee clearly affected how I felt for the rest of the day. So, those would affect one another, and I would call those dependent events. This is important when I want to calculate the probability of A and B occurring together. So, if two events A and B are independent, then the probability of A and B equals probability of A times the probability of B. So again, the key here is that if two events are independent, I'm able to multiply them together if I want to figure out probability of A and B. And the key here is when I see and, I think multiply. So let's look at this in an example. So let's say this is what my kitchen pantry kind of looks like right now. And I'm going to be picking one drink and one ramen package for lunch today. And I'm super bored, so I'm just going to close my eyes, randomly pick one drink, and then I'm randomly going to pick one ramen package on the second shelf. I want to figure out what are my chances of getting a Sprite and a beef ramen package for lunch. So here I want to ask myself, okay, are these independent? Yes, they would be because I'm picking one drink on the top shelf, and then separately I'm going to pick one package on the bottom shelf. Those are two separate events, and they're not really influencing each other because I'm just closing my eyes and I'm randomly picking one. So how I'm going to break this down, I'm going to find the probability of getting a Sprite, which is 2 out of 6 because I have 2 Sprites out of 6 total sodas. When I see and, I think multiply. And then for beef ramen, I have 5 beef out of 9 total ramen packages. All I have to do here is multiply those two probabilities together, and I see that I have a 5 out of 27 chance. The next thing we're going to talk about, if two events cannot happen at the same time, they're considered to be mutually exclusive. So this is important in terms of combining them. So if events A and B are mutually exclusive, the probability of A and B happening together is 0. So here, before we do any calculations, let's talk about classifying events again. It's important to pay attention here and to notice that independence and mutual exclusivity are two separate things. They mean two different things. So here I want to ask myself, are the following events mutually exclusive? In the first example, you're a sophomore and a junior in high school. So I want to ask myself, can both of those occur at the same time? Here I can clearly see I can't be a sophomore and a junior simultaneously, so these would be considered mutually exclusive outcomes or mutually exclusive events. On the other hand, what about you being a junior in high school and you taking Algebra 2? Clearly here I could see, like most of this class is juniors and you're in Algebra 2, so clearly there's overlap there. So these would not be mutually exclusive. Sometimes I think it's helpful to just call that overlapping instead of saying not mutually exclusive, just because sometimes then you're dealing with like a double negative. So if you want to think of it as mutually exclusive and overlapping, and those are kind of like the pair up and opposites of each other, I don't know. Personally, for me, that's kind of helpful to look at it that way. So this is important if I'm trying to calculate the probability of A or B. If I want to find the probability of A or B, when I see or, I think add. So what I'm going to do is I'm going to add the probability of A plus the probability of B, and then I'm going to subtract the overlap. So I'm going to subtract the probability of A and B. So I would definitely write this formula down. You don't need to necessarily write the next one down, but just pay attention to what I'm saying here. If two events are mutually exclusive, so if A and B are mutually exclusive, what we talked about a couple slides ago, is that this right here would be 0 because there's no overlap. So if you have mutually exclusive events, I could just add those probabilities together. I would say you don't necessarily have to write this down because sometimes I've noticed when I've taught geometry in the past, it's kind of confusing to think of these as two separate equations. How I would go about this is when I see or, think to add, and then in your last step, just remind yourself, think, is there any overlap? If so, I need to subtract that in the very end. So finally, we'll end the day by talking about adding probabilities. In my first example, I'm picking volunteers at an assembly. There are 50 freshmen, 28 sophomores, 42 juniors, and 20 seniors. And I want to figure out what's the probability that I pick a freshman or a junior. So when I see or, I'm going to add. So I'm going to add the probability of freshman. So 50 out of 140, I got that 140 by adding all the freshmen, sophomore, juniors, and seniors together. Plus, because I'm doing freshman or junior, the probability of a junior, which is 42 out of 140. Very last step before I calculate, is there any overlap here? No, there's not because I can't be a freshman and junior at the same time. So when I add these together, I get 92 out of 140, and if I want to simplify that, I get 23 out of 35. In my second example, let's say I'm picking a random person from class to go to guidance to go over their schedule for next year. And when I went around the room in the beginning of the semester, seeing what you wanted to take next year, around 45% of you said you wanted to take pre-calc, around 30% of you said you want to take financial algebra, and then there was also a small percentage of you that expressed interest in taking both classes next year. So, with that being said, let's say I'm trying to figure out the probability that you plan on taking pre-calc or financial algebra. How I'm going to start this problem is I'm going to add the probability of pre-calc. I'm going to change that to 0.45. It's just a good habit to get into to change your percentages to decimals, or at least that's just what I always do. Plus the probability that you take financial algebra. And then here I'm going to ask myself, is there any overlap? In this case, there would be because there's a small percentage of you that want to take both. So I'm going to subtract that overlap, which is 5%. And again, why I'm subtracting that is because that 5% of you that said you wanted to take both classes, I counted you in that 45% for pre-calc, and I also counted you in that 30% for financial algebra. So I'm double counting you right now. So I need to get rid of that double count, and I'd be good to go there, and that'd be a more accurate answer. From here, I just add and subtract these numbers together, and I get 0.7, and back as a percentage, that would be 70%.